What's up everyone, trust you're doing very good. Right here in this video I will show you what a local built power amplifier look like. Although the casing is red made, but what is inside is a local build. Actually this is not my own personal build because I don't build this way. My own is much more neat and professional like this. Someone brought this for repair, so I just decided to show you guys so that you see what it looks like. Because I like my own heatsink too. So 1 year, you understand, my preamp separate, then everything will be very neat, like at least 60 to 70% of that of red made. But in this case, this is what we have here, so let's just use it for explanation purposes. And if you want me to do a video on how to build something like this, I can do that, because mind you, this amp is this local built amps, they are very strong. They are very strong. Let me plug it so that you see it. You can see my AC here. I've connected there. You can hear the sound of my fan. It's AC fan, so it will definitely be noisy. Let me grab the cord so that you hear. You can hear the sound there. So that's it. It's working perfect. Each channel can power at least 2 speakers conveniently. Let me move to the second channel and test. You can see it, so it's working perfectly. Actually the 3 were dead before, but I just fixed it. But let me use it for this explanation purposes. So if you look at it very well, you see that first thing to take note of, my AC was here, my AC outlet. So that means the light from my socket here flows through my power cable, and from there straight into my AC. You can see it, AC input. Yeah, AC input. So it will flow from there straight to my switch, and from my switch it will send to my transformers. You all know transformer has the primary side and the secondary side. You can see this one is the local built transformer, not the red made one, so that's why it's not looking very fine. But they are very strong, very rugged, because the power of your major amplifier starts right from the transformer, because the one supplying the voltage and the current. So if it is not strong enough, then there will be drop, you understand. So this one has a primary side, the secondary side, like every other regular. So my primary side is here, while my secondary side is this side here. So from my primary, don't worry, I will still do the detail video when we are building it, you will understand it. But just for you to see what it looks like, although I don't like this one, it's a bit rough, but since I cannot start rebuilding it from scratch, mine is just to repair and make it functional. So right from my AC, for your AC, we only have 3 pin. We always have 3 pin out. The voltage, let's say 40. For example, it can be any voltage, sometimes 30, 40, 50, based on what you want. Let's say 30, now 3 pin like this, so 30, the middle will be 0, the other one will be 30. You understand? So from that, because at this stage it's still AC, just that it has dropped from the 220 to, let's assume, 40 volts now. So if 40 volts is coming out from here, then it will come to the rectifier. You can see my diode here. It's a 4-legged diode. It has 2 the AC pin, then the plus and minus. So from there, when it comes from this transformer, it will enter the diode, then from the diode it will now send to the capacitor. You understand? There is a way we loop the capacitor together. I will still do that in my next video. When I'm building one, I will show you. You can see we have 2 different type of capacitor. In this case, you can see this big one. We have this normal 100 and 10,000 UF. They combine it together. So they combine it to make it more strong a bit. So AC, step it down to like 40 volt, that is 40 straight to my rectifying diode here. Then from that diode it will strain straight. Once it's out from the diode, it is DC already. Then it will send to my capacitor. Then at this stage of the capacitor, what happened here, the person who built this is funny. So from the first voltage will come here, the second voltage comes here. So for each side of the preamp that needs voltage, so they tap it from here. So let's say this is the positive side now. The preamp 1 peak is on positive from here. The preamp 2 peak is on. This is a negative. The preamp 1 peak is on here. The preamp 2 peak is. So to the person who built this now, this is like a fuse. Ordinarily, I don't agree with it, but That is what I build here, but I'm just trying to explain so that you see. Don't worry, when I show you another type of amp again, you understand, another build, you see how neat and more professional some of them can be. But it's still the same process, you understand, just that the wiring may be too complicated at times, you understand. So just know that AC to the rectifying diode, from the diode then to the capacitor, then from the capacitor is fully DC, you understand, and sending straight to our preamp. Then I know this preamp itself can power a speaker, just that the wattage is low, so that is why we need more transistor, you understand. So based on based on how strong you want the amp to be, like this one now is 4 aside, just that they are sharing the same heat sink, so they combine the 4, and there will be 4 PMP one side, 4 NPN at the other side, then 4 at the other side too. So that means 8 transistor per channel, you understand. So in summation, that is 16. Although sometimes, depending on the need of the client, sometimes just one channel can use the entire 16, you understand. But this one is 8 aside, not bad anyway, not bad, because the major strength start from the power transformer and also your transistor. But mind you, if you have a small transformer, don't just increase your transistor, or in the sake of the more the transistor, the more the wattage. Don't deceive yourself. If your transformer is not capable enough of supplying enough current, especially current, because even though the voltage is 40 or 50, for example, let's say 50, if your current is like 1 amp, or let's say 2 amps, you can't compare with a transformer of like 5-10 amps. That one will drive more, because once the signal is heavy, it tends to require more power, so your transformer may not be able to withstand that. So you have to, so the number of transistors you use will be depending on the capacity of your transformer. So guys, that is just the way it works. So AC supply straight to our switch, from our switch to our transformer primary side, and from the primary side straight to the secondary side, from the secondary side here to send to our rectifier through the AC. Then the rectifier has positive and negative, then it will send to the capacitor. Then once it's sent to the capacitor, then it will be sent to our transistors and our preamp. Then from the preamp, if you look at this particular preamp now, this is the major input of it. You can see from this input it will send straight to the volume, then the ground to there, sending to the volume, then from there to sending to the output and the rest. But if I say I should keep explaining, I don't want anybody to have a headache here today, so let's just keep it simple. By the time I start a series, very soon I will start a series where I will build a complete detail amplifier like this from scratch. This is what I do full time. If you check my workspace, you can see everywhere loaded. So this is what I do full time. So just ensure you like this video, subscribe, so you don't miss out when I'm starting that new series on amplifier building. It will be very, very professional, and it will save you cost here. Let's say you don't have money to buy like 5 amp, for example, for work. At least if you have 2 brand new and you have 2 building, that will go a very long way. So like this video, subscribe for more. Thank you. See you in my next video. Peace.